The transistor. It's pretty much the building block of our entire digital world. But this tiny little device has a secret. It's not just one thing. It's actually got three distinct personalities. And how it behaves? Well, that all comes down to how you connect it. So let's dive in and really unpack the three faces of the transistor. And it all started right here. Back in 1947, a few brilliant scientists at Bell Labs, Bardeen, Brattain, and Shockley, created this thing. This was the very first transistor. And honestly, it was a total game changer. It replaced those huge, clunky, power-hungry vacuum tubes, and it paved the way for, well, everything, from pocket radios to the very device you're watching this on right now. But here's the thing. This amazing device gives us a little puzzle to solve. See, it has three terminals, right? An emitter, a base, and a collector. But a standard circuit needs 4 connection points, 2 for the input signal and 2 for the output. So you've got 3 pins, but you need 4 connections. How on earth does that work? Well, the solution is just elegant. It's so clever. You just share one of the terminals. You make one of those 3 pins a common point that's connected to both the input side and the output side of the circuit. And that choice, which terminal you decide to share, is what defines the transistor's entire personality and its job in the circuit. So that brings us to our first personality, what we call the common base configuration. And as you can probably guess from the name, this one is all about making the base, the shared, central point. Okay, let's take a look at the circuit here. The input signal, that comes in on the emitter. The output, we take that from the collector. And right there in the middle, tied to both, is the base terminal, which we usually just connect to ground. So the signal basically flows from the emitter straight through the transistor and out the collector, using the base as its reference point. So what's the deal with this setup? What's its special talent? Well, the common base configuration is amazing at amplifying voltage. You put a small input voltage in, you get a much bigger output voltage out. But, and this is a big but, it does not amplify the current. The current gain is actually a little less than 1. This makes it a really specialized tool, perfect for things like high-frequency circuits, where boosting the voltage is the only thing that matters. All right, let's move on to personality number 2, the common emitter configuration. Now this is the superstar. I mean, this is hands down the most popular, most widely used configuration in all of electronics. So in this circuit, the roles have kind of shifted. The input signal now goes into the base. The output still comes from the collector, but this time the emitter is our common terminal, connecting both the input and the output. And what happens is, a teeny tiny current going into the base can control a much larger current flowing from the collector to the emitter. And that right there is why this setup is so incredibly popular. The common emitter configuration is the powerful all-rounder. It gives you both current gain and voltage gain. That means it can take a really weak signal, weak in both current and voltage, and just make it way, way stronger overall. This powerful amplification is exactly why it's the workhorse for things like audio amplifiers and just countless other circuits. And that brings us to our third and final personality, the common collector configuration. And, you guessed it, this one has its own unique and really important job to do. Okay, let's trace the signal path one more time. The input gets applied to the base, just like in the common emitter setup, but here's the twist. The output is taken from the emitter. This leaves the collector to be the common terminal connected to both the input and output sides. So, here's the key thing to remember about common collector. It's pretty much the mirror image of common base. It gives you a lot of current gain, but its voltage gain is actually less than 1. It doesn't amplify voltage at all. So what's it for? Well, its special skill is acting as a buffer. It can take a signal that has a high voltage but can't provide much current, and it transforms it into a signal that can drive a heavy load, like a big speaker. So there you have it, 3 configurations: common base, common emitter, and common collector. You see, they're not just random options. They are 3 distinct tools, and a good engineer knows how to pick exactly the right one for the job at hand. And this table right here just sums it all up perfectly. Think of the transistor like a multi-tool, If you need to amplify voltage but you don't care about current, you fold out the common base tool. If you need a powerful all-around amplifier for both voltage and current, you grab the common emitter tool. And if you just need to boost current to drive a tricky load, you pick the common collector tool. It's the same device, but it gives you 3 completely different functions. Which really leaves us with this final thought. A transistor isn't just a single static component. It's this incredibly dynamic, versatile element whose whole personality can be changed just by how you decide to wire it up. It's like a circuit chameleon with a different mode for every mission. And that flexibility, that's what makes it one of the most important inventions of all time.
Thanks for watching. Stay tuned.